Here are the instructions for part 3 of Lab 15. It has been a long journey. And we are now looking at the third objective from the front page, which is to be able to name an igneous rock based on its texture and composition. So in the first two parts of the instructions, we looked at texture and we looked at composition. So now you should be comfortable using these two features to name an igneous rock. So let's go ahead and do that. Remember from the last video that we're going to look at texture in this column, and it's either going to be coarse-grained or phaneritic, fine-grained or aphanitic, or glassy, which means having no minerals at all. We're not going to use this texture called pyroclastic just to simplify things. In terms of composition, we're going to look at felsic. We're not going to use this intermediate category. Intermediate composition, mafic, and ultramafic. And in some cases, we'll use color as the proxy for these compositions. And in other cases, we can use the presence of various minerals. Now, I know we haven't had a lot of time using minerals, so that one's a little tricky. Remember also that everything in yellow indicates the type of rocks that are going to be in this lab. I am not going to give you any rock names that are not listed in yellow. Well, except one actually, but we're going to do that one together in a bit. So first of all, you have to know where to look for the videos. Go to our main page on modules and look for mineral and rock videos, and go to Igneous Rock Resources. On this tab, you'll find 3 different resources, and the first and third one are good places to go and check out what granites look like, and gabbros, and rhyolites, and basalts. But this one in the middle is the one that has all of our rocks for this lab. If you open it, you'll see a spreadsheet with 24 different rocks, all beginning with the letter I for igneous. And then you select one at a time and you watch the little YouTube video. So we're going to start with I1. And this is what you'll see. In this case, you'll see a 53-second video of this rock right here, I1. And then you're going to fill out the information on the table for igneous rock unknowns. I want to make sure that you label these in order, but don't do it just yet because I'm not assigning all 24 rocks. I am assigning I1, which we're going to do together right now. So the first thing we want to do is figure out the texture. And remember, texture means, is it coarse-grained or is it fine-grained? If you look at this rock here, you can see individual minerals pretty clearly. There are light-colored ones, there are dark-colored ones, there are some gray-looking ones, but you certainly can see them. So we're going to go ahead and call this coarse. If you have a coarse texture, then you're going to fill out these 2 columns. You're going to try to estimate the amount of felsic and mafic minerals in the rock. Now, I don't need you to list them because we really haven't gotten that far. I just want a rough percentage. Is it half and half, 50-50, light and dark minerals? Remember, felsic are light, mafic are dark. Are there more mafic minerals than felsic, in which case you'd use kind of this second combination? Or are there more felsic than mafic, in which case you'd use this third combination? Here's a closer look at igneous rock number 1. You see a lot of glassy looking minerals that are kind of gray, and that is actually the mineral quartz. Then you'll see some very white looking minerals, and that's a feldspar. It's hard to tell from this picture whether this is potassium feldspar or plagioclase feldspar. And then there are some dark minerals as well that might be biotite or hornblende. But they certainly don't make up the majority of the rock. I would say that this rock definitely has more felsic material in it than mafic. So I'm going to go ahead and select this choice. More than half is felsic, less than half is mafic. Now, this is not an aphanitic rock, which means fine-grained, so we don't have to fill out that column. And this rock is not porphyritic, meaning there's not 2 population sizes, so we don't have to fill out that column. Composition we can actually calculate from what we've done over here. If we have a 50-50 mix of felsic and mafic minerals, we could say the composition is intermediate. If we have more mafic minerals than felsic, then we either have a mafic or an ultramafic rock. And if we have more felsic material, then we have a felsic rock. So we're going to go ahead and call this a felsic rock. Do we have any other features in there? Vesicles? No, nothing in there like that. So now we need to come up with a name. And now we go to our rock chart. So we've decided we have a felsic rock, so we have something in this column. We've decided we have a coarse-grained rock, so something in this row. And lo and behold, we have a granite. And so we put the name granite over here. And that's the way it works. So these are the 12 samples I'd like you to try to identify out of the 24. I1, which we've already done, I4 through I10, I17, I20, I21, and I23. And if you do have a rock kit, a PCC rock kit, this includes all 9 of the samples that you have. So you can look at them as well as watch the videos. And then I've also sort of narrowed down what you have to choose from. There are going to be 2 granites, 1 diorite, 1 gabbro, 1 peridotite, 1 anorthosite, which is the weird one that I'm going to show you, 1 rhyolite, 2 andesites, 2 basalts, and an obsidian. We're skipping number 2 and 3, so let's go to number 4. This is what number 4 looks like when you start watching the video. This is a 55-second video. And you can see in both of these pictures that there are definitely 2 different size crystals. There are these large white crystals, and then there's actually some tiny black ones. And then the rest of the rock looks kind of gray. We call that the ground mass. So we're going to call this a fine-grained rock, as well as porphyritic, because remember, porphyritic means there are 2 crystal sizes in the rock. So we don't have to fill out this column because this is not a coarse-grained rock, but we do have to describe the color and if there are phenocrysts. So let me remind you about porphyritic rocks. This looks kind of like a potato, but it's actually a rock, and these are supposed to be crystals that are large. Those are called phenocrysts. Okay, so if we have a rock with 2 different size populations, the large population are the phenocrysts. The rest of it that's surrounding all of those phenocrysts is what I call the ground mass. And that's going to be described here. So I think the ground mass looked kind of gray. The phenocrysts I identified as feldspar, but if you don't know what they are, just say that they're white or black. I kind of left out the black ones here because they were tiny, but you can just describe what they look like. Now, what are we going to do for composition? We don't have any percentages of felsic and mafic minerals. We only have a gray overall color. So in this case, we're just going to have to use these colors up top. Is it pink or white overall, gray, gray-black, or black-green? So this rock is pretty gray, so we're going to call it intermediate. So that's what we're going to put here. We don't have any features. I don't really know why phenocryst is here. It's kind of repetitive. And now we have to name our rock. So we have an intermediate composition. We've decided that it's fine-grained. So lo and behold, we must have an andesite. And there we put the name andesite for this rock, named after the volcanic rocks of the Andes in South America. Let's jump ahead now and look at rock I9. Here's a picture of I9, and this is a very unusual rock, and it's made pretty much of 1 mineral, calcium-rich plagioclase. This whole rock is just made of plagioclase, feldspar. And here you can see some striations. If you recall, plagioclase has those distinct striations. So this is a coarse-grained rock, and even though it's only made of 1 mineral, that mineral is calcium plagioclase, which is considered a mafic mineral. You just have to trust me on this. I'm not going to be asking you about this particular rock in the future, but you have one in your kit if you brought a kit home, and so I want to talk about it. It's not fine-grained, there are no phenocrysts. So its composition, believe it or not, because calcium plagioclase is considered mafic, is mafic. And there are no special features. So let's go to our rock naming chart. This is a mafic rock. Even though it's not gray or black, I know this is one that kind of bends the rules. It's coarse-grained, and so it isn't a gabbro. It's this anorthosite, which is plagioclase only. So I wanted to show it to you, even though it's not one of the ones that's in yellow here, because you have it in your kit. And also, if you look at the moon, usually you see 2 colors up there, and those are rocks, not cheese. The light color is anorthosite, and the dark color happens to be basalt. And so those are the 2 rocks on the moon. So we're going to give it the name anorthosite. And anorthosite is a pretty unusual rock. We don't really know how it forms. It's pretty rare on Earth. Some of the more common anorthosite deposits are Precambrian. It's typically associated with mafic rocks, and there's a bunch of it in the San Gabriel Mountains, which is kind of cool. One idea is that it might be formed when magma comes to the base of the crust and ponds and starts to fractionate. And as it fractionates, I'm going to blow up this section right here. Mafic crystals settle, that's crystal settling. And then what's shown in the yellow color are these plagioclase crystals that rise because they're less dense, and they actually form sort of diapirs, and they rise through the mush of the top of the magma chamber, and then they form their own plutons, and then you get anorthosite. Anyway, they're a very, very unusual igneous rock. Okay, last one, I-20. So here's I-20. It looks almost like a sponge, but it is very fine grained. There are not very many minerals in there. There's a couple little specks of things, but if you looked at it with a hand lens, you really wouldn't see any minerals. So we're going to call that fine grained. So we don't have to answer this column 3. We're going to say it's dark brown, and dark brown is going to give us what we call a mafic composition. There are no visible phenocrysts in this rock, although I believe the one that he has in that hand sample might have a few. There are vesicles. That holy sponge-like texture is vesicular. Gas bubbles came out when this volcanic rock erupted, and they are kind of frozen into that rock. So we got a mafic composition, it's fine-grained, and so we have a basalt. And we call it basalt. I have done 4 of these for you, so let's adjust our list on the right. Now you only have 1 granite left to find. The anorthosite is done. You only have 1 andesite left and 1 basalt left. So basically you have 1 of each left on this list to find. Only thing left to remember is that there are 6 post-lab questions that you should answer at the end of the lab. I know it's a tough lab. Do your best to try to identify the rocks. Remember, you get graded on trying, not on getting the right answer, but do your best and see how you do. Good luck.